Hi, dear followers, and welcome to another video. Today, we will do the following exercise. The dot will go from one edge of the matrix to the other. And then this will be the first part. In the second part, which will be the other video today, we will add more advanced version where it will bounce from the walls and move diagonally. And let's dive into the code. Before we start working on the code, I first want to show you the connection diagram. We've already used the dot matrices in the past, but this is on page 112 of the book. This is the connection. The VCC is the power, goes to 5V as always, GND to GND. The IN, CS, and CLK go to 12, 11, and 10 respectively. Please don't confuse the order, otherwise it's not going to work. It will turn on just random dots. And let me make the video feed bigger. And again, as always, we are going to open a new file and save it. I will name it matrix dot bounce and so we've already done this in the previous the letters video of the dot matrix, but let me repeat it again. Let's first set up the matrix. I will come to the very start of the program and add these two lines of code. Let me remind you, the first line, include library, means it's gonna import all the functions that execute on this device, and let control LC equals let control 12, 10, 11, 1 means that the matrix is connected from 12, 10, and 11 respectively. And we have to put 3 more lines in the void setup. So let's compile. If you have not done the previous exercise with the dot matrix, this code might not compile for you. The reason is it will probably bring an error such as let control.8 library missing. If you have this problem, go to sketch, include library, add.zip library. I've already done that in both videos of the controlling the dot matrix. I also showed how to add a library in the very first original video of the channel. So please go back and have a look. All we have to do is sketch, include library, add.zip library. And then from the code files that you have, you just add the let control.zip library. And the next step is the following. We always just test we always just write a very basic code to test if our connections are working in general at all. Again, compile. I'm just going to turn on the fourth row, fourth column. I want to remind the counting starts from 0. 3 means fourth row, fourth column. True means it's going to be on. And here we have it. And after this test, let's write a basic code to run the dot from left to right. Let's create a variable that will keep the position where the dot is, the column. And in this case, we will keep it on the same row. We will name it pos, which is short for position. And let's write a for loop that changes this position from 0 to 7. So position starts at 0 at every iteration of for loop. It continues until as long as it's smaller than 8. The last number will be 7. And position plus means position is increased by 1 after each iteration. And at the start of every iteration, the first thing we need to do is turn off the entire display. Then we turn on the column we want to turn on. I will keep it on the fourth row. And for column, I will write pause. And true means it will turn that dot on. Clear display already turned the entire display off, so we will not have any lights that are on from the previous round. Let's add delay 200 to see, to have enough delay to see each position of the dot. And this should be the easiest way to do this exercise. This method has a disadvantage because now if you want to add something else, I'll talk about more about this in the next video, but now if you want to add something else, basically the entire for loop has to be executed if I want to do other things. If I write something else, I have to do it in the for loop and it will interrupt what the for loop does. For this purpose, let's try to achieve the same result directly in the void loop to avoid using for loops. So at the start of each iteration, we will again have to turn everything off. And then we have to turn on the LED dot that's supposed to be on. So it will be 0. Again, the fourth row position true. And then so far, everything seems the same. The only thing we're missing, the position is not changing. So let's add this line for the end of each iteration to add the position by add 1 to the position. Please pause the video here and think what's going to happen. So the answer is our count for the position starts from 0 and it continues to increase 1 by 1 after every iteration, and it never goes back to 0. It never goes back to the start of the row, and so it will be 6, 7, 8, 9, 10, etc., etc. And all the numbers that are bigger than 7 or simply 7 are going to be ignored. So this is what will happen. We reach the end, and the program just doesn't know what to do. It just turns off everything. No light is on. After I restart Arduino physically, see, the same thing goes to the end and just disappears. So we are missing the last part of this. We are missing the part where we bring back the dot. For that, this is what I'm going to do. I say every time the position becomes 8, make the position 0 again. Make the position 0, it means it's going to be 0, 1, 2, 3, 4, 5, 6, 7. As soon as it becomes 8, it's not turning on 8. It goes back, jumps back to 0. So it starts here and then jumps back to 0 and continues to increase and again jumps back to 0. So here we have achieved the exact same result as we would with a for loop. The difference is that now, as we are avoiding using a for loop, we can add more commands inside here, and those other commands are not going to interrupt what the horizontal position of the dot is doing, and then we will be able to independently add a second dimension in the second part. This is all for the first part of the video, and see you in the second part.